Why the students or the learner in general, they struggle learning calculus? It's because they start learning calculus without mastering previous content. This is my answer. And I invite you to be part of the discussion, part of the learning community that is math topics. Why the people do not understand calculus? What is so difficult with calculus? And what is the reason that they do not understand the calculus topics or the calculus questions? I have a table right here, a table of value, showing you the 2024 score distribution for math and computer science, but I'm going to target math, from College Board AP Calculus exam. Notice here that this is a scale 1 through 5, and the students pass this exam if they score a 3, a 4, or a 5. In last year, or this year, 2024, because this test is during May of 2024, only 64.4% of the students pass the test. This is not a satisfactory number, and I'm going to tell you why. Look at the numbers of the students who failed the test. If we random here, we have 23. We random here, we have 13. Approximately, we are talking about 23 plus 13. We are talking about 36% that they fail. Okay? So, why? Why we have a significant number of students failing? A significant number of students that only score a 3. Why? It's because they are not ready for calculus. The students who are enrolling in this class, they already cover or learned all the mathematics of high school. I'm talking about Algebra 1, Algebra 2, Geometry, and even pre-calculus. So what is the reason? Because before we start learning calculus, we have to make sure that we master the most important topics before taking calculus. This is the purpose of this video, to show you what you need to know in order to stop that frustration that we do not understand calculus. We have to start understanding calculus. To understand calculus, you have to watch this video. Let's see it. I have some comments from our viewers or subscribers that they express themselves about what is needed for calculus. I have excellent comments that I will share with you, some of them. But basically, we are talking about prerequisites. What is needed? Okay, one of the subscribers asked the question, can you create a video about the prerequisites in order to learn calculus? Calculus is one of the highest expressions of the mathematics. And if you are planning to learn calculus as a person, as a hobby, or as a student, or learner, or you are a teacher that wants to teach calculus, students need to know some important foundations. They need to master some important foundations. I'm talking about number sense is the first foundation. Number sense. Okay. Why number sense, or what I call number sense? I call number sense a profound understanding of arithmetic, a profound understanding of the number system. No, it's not only the number system 1, 2, 3, 4. It's the entire number system. I'm talking about the real numbers. Students or learners, they need to know exactly what real numbers are, the operations with real numbers, not only the 4 basic operations, the structures of the real number, a profound knowledge about rational numbers, a profound understanding of irrational numbers. And when I said profound understanding, I'm saying rational numbers Okay, yeah, they are fractions. But many students, they do not attach to rational numbers, that is a way to express numbers as a fraction, A or B. They need to understand that is needed to express the power of the expression and the weakness of the expression. This is critical in number sense. That's what I call profound understanding. Because every time that you, as a viewer or learner or teacher or student, write A over B, in your mind, you must state that B cannot be zero. And you have no idea. You have no idea how powerful is A over B, and B cannot be equal zero. Because this is the the base of a building. So number science is the base of the building. In the evolution of the mathematics throughout the history, arithmetic is coming first. And then we have geometry, and then we have algebra, and then we move to calculus in the 1700s. Leibniz and Isaac Newton. But if we only say that the rational numbers are just fractions, and we do not say everything, B cannot be equal zero, then later on the students cannot understand that when they have a function like this, talking about 1 over x, they cannot understand vertical asymptotes. They cannot understand domain. They cannot understand range, because this is another prerequisite. Algebra. And what is inside that algebra? The function field. So the connection between an expression like 1 over x and the understanding of the behavior of the function 1 over x in the future is coming from the number sense mastering of A over B is a rational number and B cannot be zero. So x cannot be zero. So we have here something that is not the same as y equal x, because y equals x, we have no limitation. So that's why it's important the understanding of number sense. Rational numbers, irrational numbers. The different ways to write numbers, like exponential form. Students need to, and this is more in the algebra prerequisite, how to work with exponential. Every time that I teach exponential, I said, this is another way to write numbers. But it's not just to know that 9 is 3 to the second power, and 3 is the base, and 2 is the exponent, and 2 means that 3 times 3 is equal to 9. It's not only that. To understand calculus in the future, you have to understand the multiple relations between that expression, 3 to the second power equals 9, because we can have properties of exponents, and we need to dominate the property of the exponent. We need to dominate a to the power of negative k, which is 1 over a to the k power. We need to dominate that. But it's not only the memorization of the property, but it's how that works, because this is fundamental to understand calculus. That we can apply properties to structures and they do not suffer any change, because there is something in mathematics that is called equivalence. And the students need to, or the learner needs to, and when I say student, I said every age. So equivalent. And that equivalent idea is critical, is critical to understand manipulation of numbers and variables and equations and inequalities and calculus. That 9 equals 3 to the second power can be written in different ways. But this is part of the prerequisite that I'm talking about, number sense. You have to be strong in number sense. So I'm planning to continue this series of videos about how do I teach math, how do I learn math, and I will be going over how to get ready for calculus. And I'm going to start targeting in the videos number sense. Let me know if you like that way. And we can create a series of preparation to learn calculus, and then we can move on to calculus. But this is important, number sense. This is critical. The structure when you're working with operations, this is incredible and unbelievable that students, when you can tell the student, how can you express division? The student's going to say, oh, I'm going to express division like this. Okay, B cannot be equal 0. Okay, what else? There is another way to express division. Yeah, I have this symbol here, historical symbol, A divided by B. But I want to pay attention to this symbol. I want to pay attention to that symbol because they forget that symbol later on. They forget that bar over here. And when they are dividing, I don't know, in geometry or algebra, higher courses, and they need to divide, I don't know, a square root of 2 divided by 2 divided by a square root of 3 over 5. Let's say this expression here. If they have the expression like this, they can understand it. But they never make a transition. Many of them, they don't make the transition to this expression. Let's say that when you define a ratio, a trigonometrical ratio, sine of x, and its opposite over hypotenuse, and they have an expression like this, they don't make the connection. They don't make the equivalency between this expression that they get, this is an example, this is not real, between opposite sides and hypotenuse, finding the sine of an angle. They do not establish the connection between these two expressions, that this is the same as this, and you can do the operation by doing a square root of 2 times a square root of 2 divided by 2 multiplied by the reciprocal, okay, of a square root of 3 over 5. Why? Because they have a weak understanding of numbers and structures. So we cannot think in algebra, nor even we can think in geometry and trigonometry, in calculus, if we don't have a strong understanding of number sense and a strong understanding of the number line, and a powerful understanding of what is infinity and what is negative infinity, and a strong understanding about infinite numbers. Because if you do not understand infinite numbers, you cannot understand limit in calculus, because limit is no more than that analysis of very, very small numbers. So this is the first prerequisite, number sense. Students need to dominate, master number sense. What is that meaning of negative infinity, positive infinity? When do we have infinite numbers? We have infinite number between 0 and 1. And we have to explain that. And we have to, it's not only to say that we have infinite number between 0 and 1, we have to explain it. We have to understand it. That the idea of approaching, the idea of running along the line, the idea you have to expose yourself or the learner to the idea. What happens if you're going from 0 to 1? Can you visit all the numbers between 0 to 1? There is a way that you can reach 1 at some point if you want to visit all the numbers between 0 to 1. If you want, suppose that every number between 0 to 1, is a house, and you want to visit that number, you want to say hello to that number, there is a chance that at some point you will be reaching the house of number 1. This is the infinite numbers idea. And this is critical to understand expressions like 1 over x. What is that expression? If you tell me what is that expression, you know that expression is approaching to 0. So if you said 1 over x is equal 0, everyone's going to say, well, no, cannot be equal 0. Oh, that expression approaches to 0 a lot. It's an approximation to 0. I changed the sign to approximately 0. That expression, the x cannot be 0, but can be 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 7, 1 over million, 1 over 10 million. That expression is approaching here. And when you have that idea, that number sense analysis, you can understand in the future the function behavior, and you can understand the limit of the function. And when you do not understand number sense in the way I'm telling you, and you plug in here, you see that this is an undefined expression when you replace the x when you're finding the limit. And you say, oh, we have no solution. No. It's because that expression is approaching to 0. This is what I call the first prerequisite for learning calculus: the understanding of the number line, the understanding of how the number works, because the numbers are the big players of the story, the really, really big players of the story. That's it. I want to finish this first video of the new series. Let's say this is the first podcast of the series about how to get ready for calculus. What are the calculus prerequisites? I'm going to create this series, this podcast, that will be very interesting. Very interesting. I hope that you like it. I want to finish with, because we're talking about number sense, I always liked to mention Peano's, the mathematician Peano's ideas, Peano's primary ideas in arithmetic. When we talk about the first numbers in history, the natural numbers, I like Peano's primary ideas. For example, that first idea, 0 is a number. Look at how powerful are this foundation of number sense. 0 is a number. The second idea is the successor of any number is a number. The successor of any number is a number. Another big idea: no two numbers have the same successor. Beautiful Peano's primary ideas in arithmetic. 0 is a number. The successor of any number is a number. And no two numbers have the same successor. Of course, from the piano's primary ideas, we cannot talk about the rational numbers, and we cannot talk about the real numbers, because another piano's idea is that 0 is not the successor of any number. So 0 is not the successor of any number. Of course, this is based on the natural number system. So I recommend that you go over piano's primary ideas when you are creating that foundation of number sense, because this is fundamental. 0 is a number, the successor of any number is a number, not two numbers have the same successor, so not two numbers have the same successor. If we extend that idea to real number, to the number line, okay, and we do not touch the number 4, 0 is not the successor of any number. So if we eliminate that primary idea for natural number system, the first three are beautiful. 0 is a number, the successor of any number is a number, and not two numbers have the same successor. We're going to start creating and building our idea about infinite numbers. Of course, piano has more ideas, like any property which belongs to 0 and also to the successor of every number which has the property belongs to all numbers. This is beautiful, no? That piano's idea is beautiful. Any property which belongs to 0 and also to the successor of every number which has the property belongs to all numbers. This is the beginning. This is the beginning of the induction principle in mathematics, that whatever happens to n happens to n plus 1 and happens to all numbers n. This is the beginning of one of the most fundamental mathematics analysis topics, the induction, the mathematical induction, that is critical to understand in the future calculus and to understand functions domain, function behavior. So I want to thank you, the new subscribers. Math Topics is growing at a bigger rate, and I'm very happy with that. I am happy that you like the channel. Do not forget to share. Do not forget to write your comments. Do not forget to share your knowledge. Do not forget to give me ideas, suggestions. And I see you in the next podcast about how do I teach math, how do I learn math, calculus prerequisites. This time was number sense. I hope you like it. Thank you so much. See you in the next video.